Today, we will try to learn more about databases. Specifically, how do we design a database? Last lesson, we practiced running basic SQL queries on an existing database with existing tables. And this time, we will try to add new tables to the database hosted on Azure. So let's get to it. First, the way we will work today, we will try to iteratively improve the database design. We'll try to improve the tables. We'll try to start simple, and then we'll try to evolve a table into something more practical. We'll start from one table and split it to more, and you'll find out why. So let's get started. Oh, lagging. This usually should show something more, but it doesn't. It's fine. It's not fine. It should show something on the right side as well. Check constraints, no. Table designer. Nope. There should be something on the right side that indicates more stuff about table. Maybe if I click properties, there should be stuff appearing on the right side. No, that's not it. Properties. Here we go. Okay, that's all I want to see. So we are using SQL Server, SQL database. And we have an existing database called Workplace X. Today, we will add a few new tables based on a theme called Workplace, as the database name suggests. So let's create a workplace. I mean the workplace table. So for now, this is a huge table, which will have everything. So I'll say we have a workplace. For now, pay no attention to types. I'll just list all the possible columns. We have a workplace. So workplace itself has an ID. It has a name. Maybe it doesn't have an ID, it just has a name. It has a name. It has a address, which is, let's say, just one line. Workplace also has country. And it also belongs to some town, city. It also has a contact number. It also has area of work, like what's the workplace for? Is it IT or, yeah, sector. Workplace sector is probably a good word for that. So that's what workplace has. But within workplace, we also have employees. So we have employee name, employee surname. We also have employee date of birth. We have employee date of employment, and we have employee date of termination, and we have employee salary. That's all the employee has. And this is a special kind of workplace. We also have pets in it, for example. So pet name, pet species, I guess. Pet age, pet, that's not important. Pet name, pet species, and pet owner name and surname, let's say. Pet name, owner name, pet owner surname. So we have everything in one table, and this might look convenient, but you'll soon find that it's not really convenient. Maybe let's add one more thing. Employee department name, and then we'll say department name, department, probably no need anything else. I'll remove these two. So that's what data we have for a workplace. Everything that we want is in one table, and it's not perfect. And it's not perfect for multiple reasons. So let's try to fix it first. First, of course, data types are wrong, absolutely wrong. Just like in C# you have data types, so in databases you have data types. However, in databases, the data types are very strict on the kind of like on constraints, how long or short things are. So we'll try to optimize for our needs. You have way more choices for primitive data types for databases because it's optimal for storing data. Anyways, for text, we have something related to char, nvarchar, char. So nchar versus nvarchar, basically the n word means that it's possible to store ASCII characters, Unicode characters, more characters than just the ASCII supports. So that's what these could be for. Nchar, or in general just char type, means that there is a fixed size text. So if, let's say, the text is nchar of 10, length 10, that means that if we enter name Tom, it will have a padding of 7 characters because it will always be a fixed size, 10. Nchar and char are fixed size, fixed length. It adds empty spaces to make it fit the size. Nvarchar is variable, so it will allow us to modify the sizes. And that's more suitable in our case. So we'll use nvarchar because the symbols can be anything. And we'll say that it's 100 symbols. For address, let's also allow 100. For country, let's leave it with 50. And let's not allow Unicode characters. For city, let's go with 50. For contact number, let's go with 20. And actually, let's go for 20. And let's not use random symbols. Workplace sector, let's go for 20 as well. Employee name, let's go for 50. Employee surname, let's go for 100. Actually, for employee name, let's also go for 100 because I should probably show a video what I mean by that. Because I should probably show a video. Oh no, what I mean by that. Because I should probably show a video. Oh no, what I mean by that. Because okay, I don't echo anymore. Sorry about that. That was an accident. Okay, I'll show you a video. Let me see. Let me remember how it's called. Longest. I love that video. It's so funny.
Cassandra
So
and her daughter.
Yeah, I see you can hear me well. The video. So just watch this video. It's a great video. You'll see my point.
Who has a very unusual name. In fact, we can't pronounce her name, but we can tell you it has over 1,000 letters. We had to create a special graphic for her name. Take a look. That is her name. That makes Letitia LaShawn look simple. Letitia LaShawn Shante. Her birth certificate is 2 feet long. She has the longest personal name in the world, according to the Guinness Book of World Records. And we want to ask her mother, what were you thinking?
I had to do something to break a Guinness Book record. I had to make sure that her name was going to be unique. I didn't want her name to be like anybody else's. Make sure.
What is her name? What is her name?
It's Roshandia, Tonishan, Vision, Keishan, Simon, Drew, Shalinda, Shirkane, Ronquel, Ninja, Shamika, Shanet, Tamika, Shawahini, Shell, Kani, Satsan, Janish, Marine, Kunsan, Kanisha, Devon, Yvonne, Lutani, Sivan, Tape, Pranky, Salaviva, Zanfisa, Jesslyn, Sijave, Loya, Vet, Sparkly, Sandra, Kate, Kati, Vishon, Orly, Vakisha, Wally, Sanetha, Shots, Mekmane, Loisa. My middle name is Kunyan Scotch.
Your middle name?
It's Kunyan Scotch.
Girl, please. Okay, go on. You're done?
My middle name is Kunyan Scotch.
Yeah, you get the point. When choosing the right length for column types, you need to consider those edge cases. You shouldn't follow them blindly because in this case, I would need 1,000 characters to fit such a name. Maybe no one in my region will ever have that name. So I shouldn't always allow that much data, because if I in advance reserve this much memory into a column, it takes up space. Even though it doesn't use that exactly, it still takes up space. So that's why we shouldn't, add too much for columns if it's not necessary. So date of birth, we will put daytime. Actually, we'll put date because we don't need time. Yeah, they didn't. So that's, I guess, the only perk for that name, that teachers wouldn't call her name. But yeah, what were they thinking? Employment date. Okay. Again, date. Again, date. Allow nulls. So here's the thing. We won't allow nulls anywhere except for something that's possible. So employee can be unemployed. I mean, a person can be unemployed, so we will allow nulls. Employee might still be working in a workplace, so we will allow nulls. Employee salary, always, well, if you're an employee, you will be getting money, so untick. Pet name, not everyone has a pet. Not everyone has a pet, so untick those. I mean, tick those, leave those ticked. And department name, everyone has to belong in a department, unless you're unemployed. Yeah. As you can already see, it doesn't make much sense. This table by itself is just too big. Also, I didn't fixed this yet. Nvarchar reserve as much space as nchar. Nvarchar reserves. I actually don't know. I think it depends. Like, the fact that it can be variable by itself costs more. So if you compare varchar, if you compare nvarchar that is fully filled with nchar that is fully filled, definitely nchar is going to take less space because that's what it's optimized for. But if you compare like almost filled nvarchar, I don't know. Maybe. I never considered that. So I would Google if you're very interested. I don't know. So money, there is a type for that. In C#, that's equivalent of decimal. Pet name. Pet name. Again, it can be weird characters, so we'll allow 100. Pet species. Actually, pet names usually tend to be shorter, so we'll go for 50. Species are short. So we'll go varchar for 30. Owner name 100. Owner surname 100. And employee department name 20, 30 maybe. Right now I'm trying to look at this structure and it's like basically I should actually mark everything like this, because everything here can be filled or it might not be filled, because I might be talking about an empty workplace or a person who doesn't have any job, or a pet without an owner, or a person without a pet. Everything here goes. And that's why this structure, having everything in one table, is awful. So I'll call this... Anyways, let's continue and finish at least one awful table. So with one awful table, we will have what? We need two things here. We need a table name. So I'll say workplace everything, because it has everything. And I'll call the schema. I need to create a schema. And I'll create a new schema and I'll call it... Schema is basically a logical grouping of tables. Like as you can see here, sales LT. So in our case, it will be workplace, a grouping. Workplace V1, I'll actually write. I need to create a schema in advance. How do I create a schema? I don't remember. Schemas. I might Google that up because I don't remember. Okay, I'll Google that up. Create schema SQL Server SSMS. Okay. Can I create schema through UI? Maybe I cannot. So it's create schema SQL statement. I will do a new query and run that. Create schema, and I'll call it workplace V1. And I'll run this and complete it. Now I'll go here and select that, which doesn't appear, but I'm sure it's there. Was it V1 or 1? Come on. Workplace V1. I'll just, oh wow, sorry. I'll just copy paste that in. Okay, this is bad news because we cannot select a schema unless we save the table. So for now, I'll just select sales LT. And I'll hit save, which will run this table. I need to remove empty column. Sorry, this one, delete. It has to have a name, so I cannot leave those empty columns. So I hit Control S, which saves this thing, not the query itself, not this window, but it adds an actual table. So if I refresh, you'll see now a new table added. Sales LT, workplace, everything. And if I refresh the database, and if I hit properties of that table, it should now allow me to change schema to what I want. Didn't. Let's go to design, which puts me in this window. Let's reopen it so that everything is definitely refreshed. Oh no, misclicked. By the way, if you wonder why it's a little bit slow, that's because I'm actually not working with a local database. I'm working with a database on a cloud. That's why it's slightly laggy. Workplace. Huh. Workplace v1. Why didn't it appear? It should be here. Workplace v1. Huh. Why is it not appearing? Weird. Maybe I need to reconnect to the database itself. I'm not sure. Shouldn't need that. I'm also not sure where can I see all the schemas. Not diagrams. Not that either. Let's connect again. What's the password? I have no idea, to be honest. But I don't remember. Well, you get the picture. Here it should appear. I don't know why it didn't appear. It should have appeared. Well, anyways, let's continue cleaning up. So here we have an awful table with a lot of optional stuff. And this kind of data is not normalized whatsoever. Let's try to do something about that. Let's try to fix this stuff. Almost wanted to say a bad word, but didn't. I'll try to put this in a split screen. If it was any faster. Oh, great. It crashed. Perfect. And I don't remember the password. but I do know where to find it. It's in the previous video. I did not copy it. I will quickly look up the previous video so that I know for sure what it is, because I don't remember. Sorry again. Okay, I have. Okay. Super dumb password. Here we go. Maybe the schema will appear as well now, so let's hope for the best. All right. Database, tables, workplace, properties. I shouldn't have done properties. Design. Is there a schema to select? Properties. Sorry, properties here. Yeah, so you actually need to reconnect the database. Okay, that sucks. That really does suck. But it's good that I dealt with this, because now you'll know if things don't work. And again, nothing changes because you need to refresh. And now you have it, our V1 stuff. Let's reconnect to the database again, but first let's add more schemas. So the schemas will be workplace V2, V3, and 4, and 5, and 6. Definitely no more than that. Let's reconnect. Connect. And I should see all those just fine now. So all good. Now we need to fix this. I'll move this here. All I want, yeah, I want those, just those. So let's try this, just like in programming, just like in basic programming, you know, when stuff is too big, you usually split it. When there's too much stuff, you need to split it. And that's what we'll do now. We'll split this big table into multiple tables. First in first normalization form. So first normalization forms says that there shouldn't be much duplicate data. There shouldn't be duplicate data in a table, and that it should be identified by a single column. That's first normalization form. And we don't have any IDs. For example, what if person has the same surname and first name? Then it's a problem. So let's fix these problems. First, I will create a table called workplace. So this is a workplace table. A workplace has a name, address, country, and city. Also a contact number. It's very easy to split it because basically we prefix something that should be a table of its own. So contact number and sector. So this is very easy. Again, I'll just rewrite what I wrote there. 50, 20, 20. I'm confused. 50, 20, 20. Yeah, 50, 50, 20, 20. Good. And let's fix these. And varchar and varchar because country and varchar because we want it. Sorry, country. Actually, country should have been varchar as well because it can have native characters. So be it. Simplicity, contact number. Just varchar and sector also. All right. And as I mentioned, last thing that we absolutely must have is ID. And ID is usually of type long, but we don't have that here. So we'll use, we can use integer. Or we can use big int. It depends on how many IDs we have. Usually it's long. I don't remember how big is big int. For our use case, int is enough, definitely. Let's move this more like this. Okay. ID needs to be marked as a primary key. Primary key is used to identify the whole row in a table. So for example, right click, select. You see, if we have a row, that's not a row, that's a row. If we have a row, ID identifies one element, one row. It doesn't identify column, it identifies the whole row. So one ID equals to one row, no exceptions. And it cannot be null. IDs must be provided. It's important. Also, a workplace must have a name, address, country, city. It might optionally not provide a contact number, but it must provide a sector. So cleaned up a little bit. When we think about IDs in a database, we should also consider that when creating them, we often shouldn't really care how ID is set. We should probably provide we should probably generate the ID somehow. And the easiest way to do so is by saying that ID will be seeded. Sorry, that ID will be seeded. So we select that it is an identity, and it basically, here you can see, ID will start from 1, and every new ID will be incremented by 1. So that's what we just did now. And that's about it. That's the first table. Last bit that I should do is set the right schema. Unfortunately, the other schemas did not load, so I will need to reconnect the database. Just workplace. Okay, give me a moment to close everything, the whole thing, and reconnect. But we did reconnect, yet it didn't appear, so that's a little bit odd. Do you need to like restart the whole SSMS? I don't know. Anyways, we did that for sure, and we should have all the schemas we want. Workplace, DBO workplace. Yeah, ID number is created in SQL. If that's the question. That was the question. Where is the ID created? It is created in SQL. It can be created in C# as well. There are multiple approaches how you can do that. But like the most usual one is from the database itself. Because, I mean, it's stuff that's close to it, stuff that it manages, why not to utilize it? But you can definitely do it yourself as well if there is a need, that is. So let's change the schema. Workplace v2. Okay. Hit save. And let's move on. Refresh the database and let's move on. The tables. So let's also open this one for reference. Move this here. Come on, move this here, move this here, there, perfect. Oh God, mixed windows. This is fine, and this is fine. Uh-oh, I think it will crash. Jesus Christ. And I have a good computer. This is not problems of my computer, 100% sure. 12 CPUs should handle this. Definitely. All right. So we want this for reference. So that we know, again, what we are refactoring towards, and we want nothing else, just a new table. Sorry, this one, table. Okay. So now we need an employee. Sorry, not an employee, but employee will have an ID. Employee will have a name and also surname. Date of birth. Date of employment. Date of termination. Employee salary. And that's it. And I'll also probably have workplace ID. So again, primary key. Primary key, int we set. Should be seated. And the name we set 100. Surname we set 100. Date of birth we set datetime. Sorry, we set date. Date. Money. And another integer. The schema will be the same, v2. And let's remove a bunch of nulls. We don't know if that person ever had a job. So these can be nulls. Again, I'm not saying this is perfect. And you'll see why, but not yet. So that's all for this table. Save. I'll call it people. So we have people table and workplace table. On top of that, we will have pets. So pets table. Pets. So has a name, pet has a name, pet has species, and pet has owner, an owner. Owner is an integer, that's the ID. Species is 50. Name is 50. Sorry, species is 30, we said, or something like that. Nothing is null. Owner might be missing because some pets might be, you know, in a shelter or something like that. And lastly, of course, we need an ID. Again, the same logic applies. That ID is an identity. Here we have it. Save, and we are done. Done with first normalization form. Little to no duplicate data. And we have everything identified identified by a single ID column, basically. So people, pets, and workplace. However, there's still a few issues, major issues. We still have stuff that's not uniquely for just a person. So a question to you guys. What person has that not every person has? Basically, what doesn't really belong to a person in this case? What belongs somewhere else or is related to something else? Name and surname definitely belongs to a person. Date of birth, that's still person. Yeah. So employment stuff is quite different from, you know, the rest. So I wouldn't associate that with the person. It should be split in another table. There should be an employees table, because otherwise, for different employments, we would create the same people, but would have different fields here, 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 and here. So not really that useful. Or even the same workplace, we might, you know, promote a person, and also we forgot a position, but who cares, right? Actually, we care, so we also need a position. So let's try to make this better. Also similar for workplaces, actually. Not this, but this. There is a workplace, and then there is address. Address is not unique to a workplace. So workplace has a name, and workplace could have those things, but it could have them split as well. It really depends. It's okay. Like, it's acceptable, but it could be better. But anyways, let's move on to second form. So second form says that, and here's where we went wrong. Second form says that people. Sorry. Sorry. Second form says that a table should talk about one thing at a time. It should not include different entities. It should only refer to one entity. So if I have people, everything here uniquely should belong to a person. And if there's something that doesn't uniquely belong to a person, strictly, that should go away. And this belongs more to an employee, a workplace, but not a person. So let's refactor that. This basically. All right. So I say name, surname, DOB. Thank you, Kinder. ID. And that's all. That is person. 100, int, and date. And that's a primary key. We don't allow nulls here. And that's all. So, sorry, varchar should have been. Cancel, because we need a schema as well. So we call this people again. And the schema is v3. Let's save. And we create another table, call it employees. Again, v3. Let's close that. So here we have person ID, ID, like employee ID, salary, workplace ID, start, end, and start, work start, maybe something like that. Work start, work end, and position. Varchar, sorry. Varchar 50 position, work and those are date times. Workplace ID is a int. Salary is money. ID is an int, and person ID is an int. So salary is a primary key. Sorry, ID is a primary key. Let's give it an identity. And let's save the table. Cool. We have that split, and that'll be good enough. That will be good enough. So, if we go to workplace once again, sorry. design. We'll see the thing that I mentioned, that everything here belongs to workplace address. That's fine. We could split address to its own thing, to its own table. But then we have also one other interesting thing. We have country and city. Can we determine country by the city it belongs to? If the answer is yes, that means basically that it violates third normalization form. Third normalization form means that we should not, like, if we can deduct stuff in a table, in the same table, that every, let's say, Manchester City will have UK as a country, we shouldn't have a table which allows us to deduct such information. We should split that into a table of its own, where we just list cities and people. Because if we have the same pairs of data, we are duplicating stuff. Sometimes it doesn't matter. In our case, it maybe doesn't matter. But for completion's sake, let's do that. So I'll go ahead and refresh the tables just to see what we have once again. We have employees, we have people, we have pets from V2, which is fine. And let's have a workplace and an address. Okay. So workplace has a name and workplace has an address ID. Also, it has a sector. That's all the workplace has. Simple. See? So varchar and varchar probably is better. Address ID long. Workplace, of course, itself has an ID. Sorry, not long, but int. Sector. Varchar 30. And workplace has an ID, which is an integer. That's it. Okay. I said this is primary and give it an identity spec. Repetition is key to learning, right? Cancel. Now properties, and let's give this a name. The name called workplace. And schema v3. We need an address, right? So we'll create a new table for addresses. Address has an ID. It has a city ID. And then it has street, I guess. I mean, not street, but yeah, sure, street. Street and house. Okay. So integer, 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 and this is mvarchar 100. No nulls allowed. And this is primary key. I should also go back and say no nulls allowed anywhere else. Identity spec. Yeah. Again, this is addresses inside schema called v3. Save. And let's create last one with cities. So it's super simple one. Has an ID, has a city, and it has a country. Again, why are we doing this? So that we don't duplicate the same country for the same city over and over again. Int varchar, so mvarchar, and same mvarchar here. And let's say this is 100 and this is a 50. Cool. No nulls, primary key, and you are an identity spec. Cool. Yeah, looks good to me. I call this cities, and it will be inside v3 schema. Let me quickly go through the previous stuff. This is definitely wrong. It cannot be nulls. I don't remember what I need to do to resolve this, but I am able to Google, so I will. Unable, saving changes not permitted. SSMS. Require table to be recreated. Okay, let's see. What's the option to resolve this? Boring stuff. Options, designers. Okay, options, designers, something. Options, designers, something. Prevent. Let's untick that. Yeah, sounds good. Save. And we're done. So we have all the tables we want in the way we want, but there's one last thing that's missing, an important bit. Remember yesterday when we talked about joining tables, we usually talk about indexes being involved, IDs, primary and foreign keys. How can we model a foreign key? We already have modeled private keys, but what about, primary keys, but what about foreign keys? Let's do that. Let's go to every table that has a connection to all other tables. Again, I clicked the wrong thing. Right click, design, and indexes and keys is what we actually want. Sorry, relationships is what we actually want. So I will add a relationship. And basically it allows me to connect tables that are related, columns through which those tables are related. So address is related to a city by city ID. So confused, haven't done this in a while. Foreign key column, primary key column. Why don't you allow me to edit you? Oh, tables and columns. Here we go. So we connect this table's primary key. So cities, primary key, ID with addresses, foreign key, city ID. You see? So primary key is the table that contains all the information. That's where we're looking for that. And foreign key is just through what column we refer back to the source of all the rest of information. So we look for all information about cities in cities table, and we can get all the info we want about a city using city ID. However, the connecting point of city information and address is city ID. So I select those two and hit OK, and we have addresses, cities, foreign key. I'll close and hit save. And now if we go to keys folder, you will see that there is a new key appearing in this section. I'm not sure if a refresh is needed or not, but it should appear. So here you have it. A dark, fully colored primary key and a foreign key. As you can see, 1 points inside the addresses, another 1 points away from addresses to the cities table. All right. Let's add foreign keys to all the tables that should have them. So again, I right-click relationships and add one. Tables and columns. What about employees? So what about employees? Employee has a workplace, right? So we connect that to an employee. Workplace ID with workplace ID. And we don't finish here. We have one more. Employee also has, employee is a person, right? So employee has that as well. Yeah, person. So we combine that with people, table, people ID. So person, like this, we combine the two entities. Again, this might mean that the same person can work in different places. With this relationship, we just modeled that. And that's all about person, really. Person has a workplace. A person is an employee as well, can be. So that's what we just modeled. And lastly, yeah, save. And lastly, we'll go to people. Sorry, not people, but pets. We didn't touch that table because it's fine. So we go to pets. And we have owner ID. So owner ID of pets should link back to the person ID. So people ID should match owner ID, as you can see here. So that's the relation. And if I hit save now, I don't know why we allow nulls. Oh, right, because we said that a pet could be in a shelter, so not always have an owner. And that's it. So I will not add data to these tables because it's a little bit outside of a scope, but you should realize what a good database looks like. So a good database or rather a good table, doesn't have duplicate data. If you look at a table and you see similar stuff all over and over and over again, just like code, don't repeat yourself. Just like normal code, follow dry principle. Split stuff. Split stuff until it's not duplicate. Sometimes it might be tricky to notice. When will data be duplicate? And if you follow 3 normalization forms, first one basically says, just put stuff, but when you put stuff, identify it through a single column. That doesn't really talk about duplicating stuff. It just says prefer not to duplicate stuff, and that's about it. Second form adds guidelines, more strict guidelines. It says that a table should talk about one thing. And initially we had people table, which talked about people and employees at the same time. So we split that to 2. And third normalization form says that you shouldn't be able to deduct one information from another column. Like you shouldn't deduct one column data from another column. For example, if you have a city, always Manchester city will be inside United Kingdom. So why repeat the pair of Manchester, United Kingdom all over again if you can simply move that to a table of its own, right? So instead of repeating a pair, you will repeat just one column. Taylor AI asked, using foreign keys means linking so you can access other more properties in C#. Will it be part of the same object? Just like tables suggest that there are different entities, so our foreign keys suggest that there is a part of an object somewhere else, or in other words, there is a part, and that part is an object by itself. Some relationships, for example, one-to-one relationship, says inheritance basically. So then it means the same model. But if you have not one-to-one relationships, you usually refer to parts, different objects. So in C#, in most cases, you will see different objects. Different tables equals different objects, not a part of the same object. So different objects. An object can contain objects, just like table contains references to other tables. And we'll talk about that in the next lesson. So to wrap things up, I would like to draw you something. All right. So let's say these are tables. And let's say these are relationships. So one to many is a relationship when there is a primary key, which refers to foreign key. That's one-to-many relationship. Now, there is many-to-many relationship when foreign key refers to another foreign key. And that is many-to-many relationship. And then there is one-to-one relationship when primary key refers to primary key. So these are 3 relationships. And ideally, the only relationship you want is this one. So this is an actually great relationship. You want this. For all other relationships, you want to do something about it before it can be workable. So for many-to-many relationship, you want a table in between. You want a table in between. So what do I mean by that? You want a table which has both things. Okay. Both things as primary keys. So then from both sides, you will have still one-to-many relationships. One-to-many. And here also one-to-many. And here in the last part, oh, sorry. Oh, no. Like this. Well, screw that. Whatever. Irrelevant. For the last part, oh, sorry. For the last part, you'll have a merge table where stuff like this is just merged into one, because sometimes it doesn't make sense to keep it separately. So an example of this could be, imagine, yeah, let's name these tables. So a person has many pets. Person has many pets. Pet has one owner. That's a situation for one-to-many. One person can have many pets. That's one-to-many. Many-to-many. So let's say this is a book. Author and book. So one author can write many books. And one book can have many authors. So many-to-many relationship. And this one, so basically the solution to this problem would be here you have author ID. Here you have book ID. And here you have both. That's how you solve the many-to-many problem. Because the intermediate table acts as a mediator between the two. And the relationship between author and that intermediate table and book and that intermediate table is still one-to-many. And this one could be person, soldier. So person can be a soldier, but not people are soldiers. Niche scenario, to be honest. It's a more rare scenario. Ideally, if here you talk about soldiers and here about people, yet your database is military, probably just merge the two into one and you'll have it. It depends. And in general, normalization, sometimes you don't even need to go that far as the third normalization form. Sometimes second one is good enough. But the key point here is that actually there are more than 3 normalization forms. There is as many as 6. And big systems for big data, etc., they will be using those 6 normalization forms. But the key point here is that you should apply the right normalization form for the scenario. For studying purposes, maybe don't bother going that far. Just pick something that makes sense to you. Those normalization forms really just ways of talking about something that's actually not so complex. Just common sense. Apply common sense when modeling data, just like you would model objects. Model data using the same principles, and you will not miss by that much, at least. I would say second normalization form can be reached through just using OP, using the same skills that you would model OP. Third one, you need to turn on your brain and think, can you deduct something, right? So that's about all I wanted to talk today. So basic database design. Not tomorrow, but next week, we will start taking first steps into entity framework and actually into old native ways of talking with database and comparing what problem do object relational mappers, aka ORMs, solve. So that'll be all for today. But before I go, do you have any questions? Would you like to ask me anything? I should also mention that as a software developer, I do not develop databases that often anymore. I mostly consume them. So consuming databases is much more important to me than knowing how to design them. Optimizing how to query them is more important than how to design them, because usually there is a dedicated person for that matter. A person who maintains database, who designs it. If you have no questions, that'll be all for today. So thank you all for watching and see you next Saturday. Bye bye.